Hey everybody, welcome to this video. We're going to be taking a look at a workflow that we built up in a previous video that focused on type hints and the benefits that these can bring to your developer experience. And in that video, we built this logic that was connecting to the Gemini Exchange, grabbing some real data about cryptocurrency prices, and bringing that into our Python environment so that we could play around with it and do some demos that are based on real data instead of some of those more classic Hello World examples. So here we're going to expand on that. We're going to take these functions that we built, and I'm going to treat this really in the same way that I would treat code in my own production environment. And that is there's certain code smells that start to waft in every once in a while where you say, does this really smell right? And in this case, one of these code smells is, all right, I see I'm using all these functions independently. So they don't really share any context between them, but in doing so, they kind of reinvent the wheel. So like this function down here, which is the one that we actually use at the end of the day to go grab all of the prices that we want and stuff them into a Pandas DataFrame, this thing is defining time frame. Oh, look at this. Its buddy up here is defining time frame. It looks like we also define time frame up here. And then there's also other things like each one of these functions is using the type checked decorator to enforce static typing. And so we start to see, even with just 4 functions, there's some inefficiencies popping up. And then not even to mention, if these are 4 functions that are all kind of working towards the same goal, what happens if I add in a 5th function that exists in this file, but it's not working towards that same goal? So then all of a sudden you have like no real differentiator between things that are supposed to be working hand in hand and things that don't have anything to do with one another. You could just start storing those in different files, but maybe it's worth introducing the concept of a class. And so what a class is going to do is it's going to allow us to accomplish this same functionality we have here while removing some redundancy from the code and also giving it more of an organized structure. And if we really wanted to get more advanced, and in future videos we'll explore this, some additional benefits that will enter the picture when you have a class that's really governing a bunch of methods that belong to it, and some centralized data so that the class can delegate things to those methods as needed. So before we dive into building the code for the class, let's just see how that function approach was working. So we had all the code defining our functions in one file, and then in this other file, we were importing that functionality, and then we were making use of that function. So we import Gemini Exchange funcs, and then here we call on that, and inside of that was that final function we cared about, get prices data frame. And with our lovely type hints that we made in the other video, we can see that symbols is expecting a list of strings, which are the symbols on the Gemini Exchange that we want to query. So those are cryptocurrency trading assets that we're getting pricing information about. Then there is an optional time frame parameter. So again, this is a really nice feature of type hinting that we can see, okay, this is optional. We don't need to pass this in. It defaults to 1 day, but if we wanted to, we could make this some other time frame. All right, understanding all of that, let's take all of these functions with us into a new file, and we are going to, I guess we're going to struggle to select all of this first. We are going to bring this all into a new file, defining some information about our classes. Now, if we see anything here today that is not super obvious, maybe you're new to classes, that's fine. There's going to be more videos down the road where we explore classes a little bit more. But maybe it also gives you something to Google about and learn on your own. It's the best way to learn, really. But for starters, we are just going to define a class. So when you define a class, you want to give it a name, and unlike functions that have this snake case format, every first letter of the word basically you're gonna want to capitalize it with a class. So for example, if we are fetching Gemini pricing data, we're going to name this Gemini Price Fetcher. Seems like a reasonable name. And it is never a bad idea to put a little doc string for your class to kind of keep you, especially while you're developing. Well, I guess not especially, equally valuable. These doc strings are equally valuable if you're coming back and reading your code. But even while you develop, sometimes it's nice to just say, what is this thing doing? And in this case, this thing is fetching, or I'll just say fetches historical cryptocurrency price data from the Gemini Exchange. That is what this class is doing. So now we are going to want to define a function that's going to initialize some data for this class. Whenever we define an instance of this class out in our final code where we're making use of the class, we're going to pass some information into it. So let's decide what that information is, and we can just steal that from whatever this final function here was using. All we need to do is pass in our list of symbols and then our optional time frame. So let's define that for the class as well. And we do that by making a init function. And if you have no idea what this is, go do a little bit, pause this video, do a little bit of Googling about this. There's so much written about this. It's not even really worth explaining here, but basically we're just making this init, is short for, initialize, and we are building a class that needs some information to operate. And that information is going to be, what are our symbols? And we said that was a list of strings. And then what is our time frame? And that was an optional string that defaulted to the 1 day time frame. Okay, so when we're initializing data for the class is going to have a bunch of, you could think of it as like it's the boss, the class is, and all the methods that we're going to have inside the class are kind of its employees. It's going to delegate tasks to these things. And that boss needs to keep some information at a kind of global scope. So that information, like when it's telling other methods to go do something, it's going to say, by the way, you're going to need to know about these symbols, or you're going to need to know about these timeframes. And the way we'll reference that is by saying self.symbols, self.timeframe. And so we need to define what that self.whatever is right here. So self.symbols equals whatever those symbols are that we're passing into this initialization method. And then self.timeframe is going to equal the time frame that we pass in. So what this is going to allow us to do, now that we can reference self.timeframe, it means that in all of these functions where we keep referencing the same time frame, but we redefine it in each individual function, that kind of anti-pattern, we can toss that out the window. We can say, that remember that smell, that code smell we were talking about earlier, it's going to kind of go away. We're going to say, it smells a little bit better in here. We're not redefining the same thing over and over again in this workflow. Okay, so let's take this function, and magically we're going to turn it into a method by indenting it. What are a method and a function? What's really the difference here? Let's just say that it's simply a label. Like when it was by itself, it was a function. Now it is a function that's bound to a class. So it's going to be, we're going to refer to it as this class's method. Okay, so we have a method here, but in order for it to know anything about, it's flying blind right now. In order for it to know about this self.whatever, well, we have to pass in self. If we want this to have access to the data that the class is using. Now, in this case, getting your Gemini symbols, this is not something that actually needs to know anything about the symbols we want to query or about the time frames. This was simply returning all available symbols that exist on the exchange. So here we can actually, we could make this a static method, but I really like to treat this as a property. Now this property decorator comes in, it does a lot of things for us we will talk about in other videos. For today, let's just leave it at this. This is going to allow me to have a set of Gemini symbols I can call on as if it's a variable. And I'm using a property here so I can use this little trick I'm about to show you to avoid having to run this same query multiple times. Like, since I'm trying to give you a feel for how I would do things in the production world, I would not want to trigger the same API call multiple times if it's not necessary. So what I'm going to do is I'm going to come up here, I'm going to make a kind of placeholder value. Let's call this Gemini Symbols. And this is going to start out being nothing. And then let's say in my workflow, I might end up wanting to know what my symbols are multiple times, but I'm only going to want to actually execute that query once. Otherwise, I'm just wasting processing power, right? So what I'm going to do is I'm going to say if self.Gemini symbols is none, then we're going to run this code that says we're going to hit this API and get all of those symbols. And then we're going to set self.Gemini symbols. Instead of being none, this is now going to become our response.json. Now we're finally going to return self.Gemini symbols. An underscore Gemini symbols here. This is just a pattern that you'll follow when you're using properties, because the property now is going to take on this name Gemini symbols. And the way that properties work is when I hit this, it's going to behave just like if I were hitting this guy. So the property is kind of treating, you're defining a function that might have logic inside of it that does stuff, but then when you interact with it, it's as if you just had a little variable defined. Anyways, I don't want to spend so much time on this, but I am trying to show you how I would build this in the real world. So now we have this benefit of being able to get our Gemini symbols, but if it's already queried that once, it is not going to waste processing power querying it again, because when it comes in here, when I say, hey, get me my Gemini symbols, and it points it to this code, it's going to say, hey, is Gemini symbols none? No, it's not. It actually has a list of strings already. So let me just give you that instead. All right, that was probably the most complex thing that we're going to talk about here. And again, in future videos, we'll visit more about these properties. But now we can come in here to this next thing, this next function we wanted to turn into a method. And for this guy, let's indent it as well. So it's coming under this ownership of our class that we've defined up here. Let's get rid of this type checked. We don't want to type check our individual methods inside this class. Instead, let's just go ahead and type check the entire class. So that's going to then apply to all of our methods. And once again, this is an opinionated thing. I like to enforce the types because it forces silly errors early. It doesn't let things like if I expect a string somewhere and I get a dictionary instead, that's a problem, and I don't want that to fail silently at the point of receiving that different type and then cause some really weird error down the road. I want it to fail right up front and say, hey, you said that this should be a string, but I got a dictionary instead. So I like enforcing types. That's up to you. That's not a hill I'm gonna die on. You can agree or disagree. That is fine. So we have this method in here, and we need to pass in, if we're going to be referencing data about our class, we need to be able to reference self. So we pass that in, and we do want to leave this as an argument that comes in. So symbol, what symbol are we getting prices for? But we no longer need this guy, because we've defined this at the class level. So again, we're removing some redundancy by moving into the class structure. And now that's going to make our doc string a little bit more simple too, because we don't need to explain what that time frame is down here, because this method doesn't actually use that, doesn't define it. We also are going to remove this level of validation, because this validation is really something that we should probably do abstract that outside of this method and do it for the class. Let's see, we might come back and do that later. But everything in here gets a little more simplified because this is just now a simple task that's being delegated by the class. But we do, if we're using timeframe down here, want to reference self.timeframe. So notice we no longer have to pass it into the method because timeframe is not being defined here. Timeframe was defined for our overall analysis or our overall class. And so we're just simply pointing to whatever was stored up here. That gives us the time frame relevant to this API call. Okay, so now let's move on to the next method. So now we have the ability to get all the symbols on the Gemini Exchange. We're getting prices for a specific symbol. Now we need to come in here and remove type checked for this new method. This one is getting a price data frame. So we get our prices up here, and then we're using this within this guy to actually turn that price data into a Pandas DataFrame. So what information does this one need? Well, it doesn't need time frame because that's defined at the class level. So again, we remove that redundant thing. It does look like we're going to need to reference the class's self. So let's pass self into this. And we're going to say, okay, get prices for symbol. What is this? Why is my IDE complaining? It says unresolved reference, no get prices for symbol. That's crazy. We have it right here, but it's not that crazy because this is a method that belongs to our class. So if we want to reference it, we need to say self.getPrices for symbol. So we can just do that down here. We're referencing our class's method, get prices for symbol. But we don't need this trash in here anymore. Let's get rid of that. Sorry, time frame. You've already been defined way up here. Okay, so we do need to reference, if you recall from the previous video, we were defining some extra columns in this Pandas data frame once we got all that pricing data. So when we populate time frame, as we can see down here, we're saying, oh, by the way, all this pricing data, it's related to this time frame. So each time you see a new price for your symbol, that's 1 day between the previous price and the one that you're looking at. So in order to reference that time frame, we do need to say self.timeframe. All right, now the final method here, the final function to convert into a method. Let's get rid of that type checked because the class is already type checked. Let's pass self in here. Let's get rid of time frame. Don't need to define it a million times. And we don't even need to pass in symbols because symbols is something that was defined at the level of the class. All right, so we get rid of that. And all we're doing is passing in self. And let's make sure that we say for symbol in self.symbols. And we're calling self.getPriceDataFrame. And we do not need this guy because that information is already available everywhere that we needed to use it. All it does is it points to the time frame up here. Now, if you're new to classes, everything we've seen here, we kind of bull rushed through it. But again, we'll have more videos talking about all this stuff. What I really wanted to illustrate was if you find yourself in this this pattern where you're defining individual independent functions that have their own independent information, and you're repeating code, like we're duplicating code here to define our timeframes over and over again. We're duplicating code by type checking these functions. Do we really need to do that if all of these functions are funneling into one final function call that's completing a specific task for us? If you're in this pattern of doing what we just described, this is a good indication that you might benefit from moving to a class structure. Here we have centralized information that's shared between all of the methods belonging to the class, and the class is just able then to delegate specific things to our methods as needed. So now let's run this. Let's just make sure everything's working as expected. So we can come out here. We could say from source.demos.Gemini Exchange class, import that class that we just made. And I'm going to comment out this. And I'm going to say, all right, let's make an instance of this class. Now we could call it anything. I'm just going to call it Gemini underscore price underscore fetcher equals Gemini price fetcher. And then that initialization method that we have out here, it is expecting when we initialize the class to provide some information. So let's do that. Let's provide it a list of symbols. And we could even see here, if we look at our IDE, thanks to type hints, we know symbols should be a list of strings, just like it was up here for this function. So let's say BTC USD, ETH/USD, and LTC/USD. And let's run this guy after we print Gemini price fetcher dot get prices data frame. All right, so what is this complaining about? Self unfilled. That might have just been my IDE being a little bit slow. Let's run this. Let's see what the complaint is. Missing a required argument self. Oh, whoops. Classic demo mistake. All right, so I define an instance of my class, but then I want to reference that instance I defined, not the class itself. Okay, so we run this. We can see if our output is what we expect. Let's even test this. Let's add in instead of a time frame of 1 day, I happen to know that 30 minutes is a valid time frame as well. So let's just test this, make sure that everything seems to be working. And now let's see if I can. You remember I said that we removed a validation step from one of our functions that used to exist. So out here we used to check, hey, is this symbol valid? And if not, we would say, uh-oh, that symbol doesn't exist. So let's see what happens now in the world of classes. If we say, I'm looking for ETH USDDDD and LTC USDDDD, which I know are not actually symbols available on the exchange. If we run this, we're going to get some kind of error, and this is no bueno. This is an error that's not really saying, hey, you don't have a valid symbol. So let's catch this. If we do receive some trash symbols, let's make sure we scrub through the trash and we identify, this symbol doesn't look like it exists on the exchange, and alert the user or ourselves that that's explicitly what is going wrong. So the final thing we're going to do here is we're going to add in that validation again, but instead of hiding it within some of these methods, this is this moving to a class structure is also allowing us to free ourselves from having to hide logic within functions. Only logic that is exactly relevant to that method should be there. So if we want to validate some inputs that are coming into our class, let's do a validate symbols method here. And this is not actually going to return anything, but what it is going to do is this thing raises an exception if the user defined symbols do not exist on the Gemini Exchange. And what this is going to look like is, if we just think about it really quickly, we know what our symbols are that have been passed in. We also have this property out here that's that if we call on it is going to tell us what symbols exist on the Gemini Exchange. So let's do a check and let's build a list of invalid symbols. And if everything is valid, if everything's just great, then that list will be empty. We will have no invalid symbols, and then no exception will get thrown. But if we detect any of these symbols that were passed to us do not exist in the valid Gemini symbols, then we're going to say, we got to stop this train. we need to fix some things. This is no good. So let's go ahead and let's build a list that's called Invalid Symbols. And this is going to be a little list comprehension here. It's probably the easiest way to write this, where we're going to say, give me every symbol, give me symbol for symbol in self.symbols. So that's the user-defined stuff. So give me every symbol in this user-defined symbols list. If symbol is not in self.Gemini symbols. So notice I'm not calling this function, this method with parentheses. I'm using this dot notation because that's one of the benefits of using a property. That property kind of behaves like a variable. It's just a variable that has some logic wrapped around it. Okay, so invalid symbols equals that, and then if any invalid symbols, then we are going to raise a value error that could be an F string. That F string just allows us to put in some kind of like interpolation, like we could put in a variable inside of that that'll get represented as text. So let's just say the symbols and then whatever invalid symbols we passed in do not exist on the Gemini Exchange. All right, so now if we run this, nothing should happen because I'm not actually using this. So when we're initializing our class, we receive these symbols, and we're going to go ahead and at the end of all of this, we're going to call self.validate symbols. And what's going to happen here is that now we are, before we really do anything else, before we delegate any tasks to our class methods down there, or to the methods bound to this class, we are going to check if those symbols are valid. And now we can see the symbols FUSDDD and LTCUSDDD do not exist on the Gemini Exchange. All right, great. So now we can come back here. We can say, let's get rid of those incorrect values and run this again. And we're back to everything being great. All right, so hopefully this video has been helpful to you. I know it's a longer one, a little demo here diving into how you can take your functions, turn them into classes, but I do think that this is a really important topic. And if you are really trying to grow as a Python developer and you are so comfortable working in functions that you stick to it and you don't embrace classes, you're missing out on a really rich kind of piece of the Python ecosystem that can really help you get to that next level. Not to say that you always want to use classes, but in this case, I think it's pretty clear cut, even with this kind of small amount of code, all these functions that we wrote are really trying to accomplish one task, and that one task is fetching prices from the Gemini Exchange. So why not build a class that describes what that process is? And this could help make this code more maintainable, more understandable if someone comes in to use it. And it also means that we don't end up in this situation where we have down the road potentially hundreds of functions and you have to have tribal knowledge to really know, oh, this function is used as an input to this other one. They really belong together, and you could really smell this if you have a big file like this and somebody then puts in a comment and says, functions for task B. And up here they might have something that says, oh, these are my functions for task A. If you're doing this, it's like, that code smell starts to waft up in the air again, and you say, maybe you want to put all of this into a class. And then it's much easier to control everything that's happening for that logic that belongs together. All right, that's it. I'm going to stop talking here, and I hope to see you in future videos. Hope you got something out of this one. So until next time.